Welcome back, everyone. Hello, and welcome back. Hi there, everyone.
Hi there.
All right.
Hello.
If we can come on back and mute your microphones, I'll also do it on my end. I hope you had a very collegial and fun time doing the math this Saturday. And what I'm going to do next is model how to do the 5 practices. If you see slide 30, that is the book that I'm modeling this next part off of. In Smith and Stein's work, they talk about anticipating ahead of time what your students will do. As I mentioned, I had 26 samples that I was ready for. You're going to monitor. You probably saw me bouncing into your breakout rooms, talking to you, asking questions, and probing. At the same time, I have about 20 pieces of Post-it notes in front of me with notes about whose slide has what on it as I am selecting specific slides to review. I've ordered them in the sequence that I'd like to do the math talk in, and I've even added purposeful questions on my Post-it notes to connect the different mathematical representations. Yes, there are so many updates that they do, even high school versions, elementary school versions. And we're going to start off on group 11 slide. They're on slide 27. Slide 27. And if this group could share with us, what were you thinking with the representation with the red arrow? What's going on here?
Hi, I teach 4th grade, and I was trying to think of a very visual way to show my students the progression of the pattern. So using color codes to show like there's the first level of the station and then what's happening at each subsequent level or stage.
Wonderful. Thank you for sharing, and thank you for bringing up the grade level too. This is absolutely appropriate for 4th graders. Let's take a look at group 4 slide. They are up on slide 20. Group 4, I put an arrow next to the representation I wanted you to talk about. Why might this be a useful representation?
Hi, so I'll explain this. I use the online math virtuals, or the virtual online math manipulatives. So I use the counting blocks. So for stage 1, it shows that there is 1, and then stage 2 shows 3, stage 3 shows 5. So it shows the progress of the continuation of adding to each time, or like the addition of to each time.
Really neat representation here. So you are seeing the 2, and I can already see mathematically that you have a sense of this +2, and you're okay with the space stations looking a little different. So the representation on slide 20 is very similar if we have a strong conceptual background as slide 27, but they're also rather different, and that might be a great leap for some students. Let's check out group 9. They are on slide 25. And group 9, can you show us what you were thinking with your table and those +2s there? Slide 25.
There. Hi, Theresa. Oh, wait, go back to the slide.
Hello.
Go back to the slide. Hold on. Okay. Just what happens each time. And we definitely disagreed on what the word pattern meant. I was just thinking when you go from one output to the next, what happens? And then, what is the other woman's name?
Alicia.
Alicia was talking about a different interpretation of pattern. So Alicia, what was your interpretation of pattern?
So
the way that we've taught it, at least that I've taught it in my classroom, is that the pattern is what happens in between the input and the output. So if you have one and you're putting one in, the pattern is and I'm doing air quotes, the rule, like what you do to it to get your output.
So I'd like to open this up to the whole group here. You can choose to raise your hand like Melanie just did and use your microphone, or use the chat box. How are these representations different from one another? For us math folks, we see similarities, but how are they really different? And what does that tell you about the students? Melanie, go ahead.
What I wanted to say was, and I said this in my chat room, we didn't know what age these kids were, or were we told at the beginning? I wasn't sure. I teach high school and I teach algebra, so they're familiar with equations, they're familiar with graphs, but you can see how certain students may not have gotten, or certain age range students may not have gotten there, and they may only see visual representations and not graphs and not equations yet. But to me, that +2, that pattern was slope. That to me was slope because I teach algebra.
Right, absolutely. Lisa, go ahead. Lisa, if you go ahead and turn on your microphone, we'd love to hear from you. All right, as she's working on that, how about Marianne?
Hello. So I just was thinking about something else as I've been looking at everybody's kind of displays and visuals and graphical and thinking about this in numbers. So in another lifetime, in my other side of my brain, I was an art teacher also. And I'm also thinking about, for example, I'm going to go to, still on slide 24. Can you guys see I guess you can't see my arrow. I'm thinking about the space between these stations and what that would look like numerically and the pattern. So for example, in stage 1, there is nothing between stage 1 or anything else. So it's 0. Between the two modules or whatever you call this in stage 2, there's 1 missing, right? 1 would fill that in. Stage 3, it would be 2. Stage 4, it would be how many? I'm thinking in the negative space because I'm thinking about this thing as a science teacher orbiting in space, and how is it staying in balance? It's not staying in balance because of just these objects, these stations. It's staying in balance because of the negative space also has a functionality too.
Awesome, Marianne. That is a great connection that you were able to make there. That where you can look at things in different ways. And actually you lead us in to the very next way that we could look at this. And that's on group 2. If we want to head up to group 2, and it's slide 17. Group 2 also saw a different way, like Marianne was just explaining it there. And they have this whole -1 thing going on. Group 2, would you tell us what you're thinking about the -1?
Yeah, hi, this is Kate. I teach high school, and we cover series and sequences in Algebra 2 and Pre-Calc Honors. So I've taught it multiple years. So my brain immediately saw the pattern as, oh, this is an arithmetic sequence. And the formula for an arithmetic sequence is how many are in the first step plus the common difference times n minus 1. So I went right to the formula because I'm an algebra teacher. But as the only high school teacher in a group of elementary school teachers, it was very interesting to hear like their reasoning as to why you are subtracting off that first one. And I'm like, oh, I wish I could like tell my kids all of these reasons because it made a ton of sense in my head.
That's wonderful that you guys were able to work vertically here, and that you were able to see the -1. Does everyone else see their representation that has this little red arrow, kind of making it dance right now? That purple one, that they didn't want that twice, they wanted the -1. And group 8 did something similar to that as well. Group 8 is down on slide 24, and they used words to explain that kind of not doubled thingamajig. Can group 8 explain what you mean in these words?
So at first I was thinking of, hi, I'm Chris, I teach high school, but I was trying to think from the elementary school level, how they would do it not using formulas, and that idea that if the input is doubled, shouldn't we just be able to double the output? But seeing that didn't work, and then seeing how the formula, the pattern need to be manipulated. So for example, doubling stage 3 to get to stage 6, if I simply double the modules, that would get me to 10, but the true number of modules looking at the table was 11. So thinking that, well, if we double both and then add 1 to the modules, we should get the number of modules.
I love your explanation and how you were able to kind of define modules differently. So this group is now saying that the answer is double the modules and then +1. We are up to 3 different mathematical ways of generalizing this pattern. We've mentioned +2, we've mentioned -1, we've mentioned +1, and we're going to mention another one, group 5. Let's head up to theirs. They have 2 different ways of looking at this and a visual to go along. This lovely visual is different than the way many people were thinking of it. Can someone from group 5 explain your visual and how you saw it? So group 5, how did you see this visual? I'll dance the red arrow at it.
So I didn't work on that part of it, but I can say that the left-hand side is showing the N, the number of little space stations, and then on the right-hand side, that's a representation of N -1 space stations. So you're kind of subtracting that 1 so that you don't account, so that you can take out that double use of that first one.
So now we have yet another representation, and we have this kind of N plus N minus 1. And the neat thing about algebra, which is what we're going back to here, is depending on the representation, depending if you're talking about slope, y-intercept, depending if you're talking about stage 3 or stage 1, you're going to use these numbers differently. And in a class with students, I would go into a deeper conversation about slope and y-intercept and how we see them differently. I might also talk about on slide 21 how they have 2 different looking equations. They have n plus n minus 1 and 2n minus 1. And I know a lot of us middle school teachers are like, well, they're just combining like terms, no biggie. But the first time I was told to combine like terms, I didn't get it. I didn't understand why you would do that. Why didn't you just keep it the way it is? But when we can see a visual representation of both, I'm more likely to buy in. So I can look at these expressions differently and still know that they're the same. Our last one to look at is on group 7. If we can come down to slide 23. Many of you incorporated things like tables and graphs, which is fantastic because too often in math, we do these in different units, but here they're all in the same slide. What this group has done is they've also included XY coordinates. And group, would you tell us, what does the X coordinate mean? What does the Y coordinate mean? And why did you think to include them? So anyone from group 7, why did you include those coordinates and what do they mean? And if you're not in group 7 and you still want to participate, make your voice heard, go ahead and type in the chat box. Why did they put those coordinates and what do they mean? And if someone else from group 7 wants to turn on your mic, you can talk about it.
Hi, this is Megan Jakes. I believe each coordinate is the length of one side of the V.
Yeah, so that's that second number, 1357. But what's that first number?
No, that's the input.
Right, our input, our stage. All right, folks, so I'm going to end our discussion because I wanted to show a couple other slides and still have everyone out on time. If you look down at slide 29, you will see my main goal of this lesson. I wanted us to think about why the answer can be +2, why the answer can be +1, and why the answer can be -1. And how when we look at different visual models, we can make sense of adding like terms and simplifying equations. On slide 31 is, in case any of you all are working with students and you would like a more specific looking slide, so it's not just free choice of how to put your answers, you could use this slide on slide 31. And if you have students who aren't sure yet how to show different representations, you might just give them the student work starting on slide 33 and just ask them, hey, how can you explain these different ones? What are the expressions you would use for these different examples? And that sets up students for making multiple representations if they're not already doing so. The last thing I'd like to do is a vertical stretch on slide 42 and 43 and 44. We got a big group. Would you please type in here what grade level you teach and how might you use this problem in your grade level? What standards does this problem hit? Take any available text box and tell us what standards are seen in your grade. There's more text boxes on the slides below. So I see examples of how this can be used in kindergarten all the way through Algebra 2 honors. Indeed, this problem is really open to students and you have the control over the conversation that you have. We could make it about growing patterns. We could make it about slope and y-intercept. We could make it about sequences and series. It's up to you what you decide to talk about. But the nice thing about this is it allows an entry point for any student, regardless of language, regardless of math ability, all your students will be able to participate in this activity when we give a nice rich task like this. Folks, the remaining slides are videos and templates that I use in my instruction. I wanted to make them available to you so they're all there for you to use. Copy and paste them as you need, and they will always be up here. I'll reset the slide deck for different presentations, but you can always view the recordings in those gray slides. The last thing I'll do is take questions on our final slide. And folks, it has been a pleasure spending my Saturday with you. I hope you're inspired to use the 5 practices in teaching math. I hope you're inspired to use rich tasks. And I hope you're inspired to have your students edit the slides and just kind of explore what it's like to be a cooperative group. Again, this is my normal. I'm happy to share it with you as this is becoming your new normal. Just let me know what questions you have, and you can pop those questions on the last slide. Finally, I have on that last slide my email address, my Twitter, the tiny URL, YouTube recordings. And if you like this and you want to do another one next Saturday, there's time slots available. We'll do a brand new task. I'm going to branch out of the algebra strand and kind of bring in some geometry, but really my strands are so muddled, you'll see a little bit of all of it. It's a task that can be given to second graders through high school geometry students. And if you like these strategies and you want to learn more, part 2 starts next week. Again, that tiny URL where that blue arrow is where you would sign up. Can we use your slides for our own classes? Absolutely. I had someone wrote me and say that they're just coming every Saturday and just using these as their lesson plans because it's, it's student centered. It's got the students doing the work, and glad to help out in that way. Do you ever share your own computer screen to show the slides in Collaborate? That's a